Okay, this is the method that we can use a calculator to find the p-value of a linear correlation between the two variables x and y in this problem. We have used the linear regression to find out the equation of the linear regression, which is this one, 0.8693x plus the constant y-intercept 2.698. And R value is 0.849 here. The next question C is slightly different because we cannot find the p-value directly from the linear regression function on the calculator. To find the p-value, we will use the calculator as follows. Firstly, we need to go to the menu statistic here, menu number 2, statistic, and then enter the data into the two column. Let me erase all the data and then enter the data again. Now for x, we enter these numbers 6.3, 4.1, 5.6, the two column, the two lists 1 and 2 in just the statistic function. 5.6, the next one in 9.2, 7.8. We need to be very careful when entering these number because only one number is wrong and the result will be completely wrong. 9.2 for y, the first value, 4.9, 8.9, 10.3, 8.9, and 9.8 there. Okay, after entering all of these values into the two lists 1 and 2, we go to the next step. Click the button 3 here for the test, and then choose the t-test here, t-test second function, and then choose the regression. Now this is the most important part. Here in the regression, linear regression t-test, we need to choose beta and rho to be different. Click the button here to choose different, smaller than or greater than. And normally most of the case we choose the different. This is the most important step because when we do not choose this function for beta and rho, we will have a incorrect result. The meaning of these two coefficients, beta and rho, are as follows. Okay, beta represent the population slope of the regression line. In hypothesis testing, which is our problem now, it is used to test if there is a significant relationship between the independent variable x and the dependent variable y. The null hypothesis typically assumes beta equals 0, meaning no relationship. So in our problem here, we have stated the null hypothesis. There is no linear correlation between the variables. And therefore, beta here must be chosen to be 0. Okay. Similarly, rho also need to be chosen to be 0. And the rho here has a slightly different meaning, which it represents the population of correlation coefficient. When performing the linear regression t-test, you can set different conditions for these parameters. Beta or rho equal to 0, testing if there is no linear relationship. Equal to 0, no relationship between x and y. So the null hypothesis stated that there's no relationship, meaning that we assume that beta and rho are both 0. And in the calculator, we choose they are different from 0. Not greater than, not smaller than. We choose greater than 0 when testing for a positive relationship, meaning that when x increases, y increases also, and vice versa, y increases, x increases. X is the dependent variable and y is the independent variable in our problem. And the other case, beta and rho are smaller than 0 when testing negative relationship, which means that when y increases, x decreases. Okay, so later we'll practice with some other example and problems so that we can choose different inequality, greater than, smaller than, when doing the linear regression. So returning to this step, we need to choose different from 0. Then x list, x here, the first list, and y is the second list, and then just hit the execute button. We will have the coefficient a, as you can see that a is 2.698, which is a constant here, the y-intercept, and b the the gradient of the linear regression 0.8693, and the p-value here, this third row, p-value is 0.0325. Again, 0.0325. P is 0.0325, and this p-value is smaller than the significant level 5%, which is 0.05. And when it is smaller than 5%, reject the null hypothesis. Remember that when it is smaller than the significant level, we reject the null hypothesis in favor of the alternative hypothesis H1, in favor of H1, alternative hypothesis, which means that it is very likely that there is a linear correlation between the two variables x and y, meaning that it is very likely that the alternative hypothesis is correct and the null hypothesis is not correct. There is a probability of 3.25% that the null hypothesis occurs. Okay, so play the video again if you want to use a calculator and find a p-value in the linear regression t-test in this problem, doing a statistic hypothesis testing whether or not the two variables x and y are related. Okay, thank you.